Hello, everyone, and welcome back to networking. Yesterday, we left off finishing over that overview. We talked about networking models. We talked about a few definitions. If you have not seen that video yet, I do recommend you go back and watch that one for a little bit more context as we dive into physical connections today. Well, physical connections, layer one. Well, the big question here, what options are there for physical connections? What's required for each? Why would you choose a physical connection over another? Well, there's three primary physical connections that are used in the networking industry. Those three are wireless, seems funky. It is a physical connection, however, utilizing physical transceivers which communicate with each other wirelessly. It is still physical layer. Second one is copper. And then the third is fiber optic. Well, wireless and copper run similar in that they both utilize wireless frequency, radio frequency. I apologize, radio frequency. This means that they might be affected by weather. They'll be affected by interference by other radio frequencies surrounding it. And they'll be affected by, wireless will be affected by walls, anything that it tries to go through. Cold temperatures affects radio frequency. The colder something is, the less that RF performs. Fiber optic is different, however, in that it utilizes light. As long as light can make it through a cable, then that connection works. Wireless utilizes the principles of IEEE 802.11. It's the governing authority for Wi-Fi. Copper might be a category cable, for example, Cat 6, Cat 5, Cat 5e, Cat 6a, Cat 6e. It's a governing authority for those as well with IEEE for those standards. But those are the primary cables are going to be category cable and coaxial cable. Coaxial cable might be oftentimes what you would see going into a television. Maybe an internet provider like Spectrum might use this. Coaxial has a longer run distance than category cable, but it has less throughput. Category cable has speeds up to 10 gigabits. Coaxial rarely is more than 100 by 40 megabits. There are some cases where an enhanced cable can go a little bit further. Fiber optic utilizes light. There's two primary fiber optic cables. One is called single mode. It utilizes actual lasers for the signal. The other one is called multi-mode, which utilizes LEDs. Single mode uses one cable to transmit and receive on different frequencies, light frequencies. Multi-mode cable uses a transmit cable and a receive cable to make one pair. Physical connections determining the need. What use cases, what need do we have for each separate physical connection? Well, there's some questions that we maybe need to answer on this. What are the physical constraints? What's the available space to run cables? Sometimes running cables after the fact can be quite difficult using existing conduit or something like that. Whereas, one single fiber cable might have 12 strands of fiber. If it's multi-mode, that's 6 separate physical connections that you can run through a cable that is the same size as one coaxial cable or one category cable. Fiber is small, and you can pack a lot of glass into one cable. There's some distance questions. Category cable can run a maximum of 100 meters or 300 feet before the performance starts seriously tapering off. And it becomes almost unusable once you get, beyond a couple hundred feet further, 500 feet, it becomes serious performance loss. Again, it's rated to only 100 meters, whereas fiber optic cable, multi-mode, can go a couple miles, single mode can go several miles for that cable. Wireless radios, wireless point-to-point radios, can go several miles as well in the correct conditions. What are the technical requirements? Well, is there a specific throughput that it needs to reach? Is there a specific, count of cables that needs to go through, count of physical connections? Um, some wireless radios have some good throughput. Sometimes they're poor throughput, but you can do some long range on them. Fiber cables, you can have good throughput and good range. Copper cables, you can have some pretty good throughput, but some pretty small range. What are the available physical interfaces? NICs, which stands for Network Interface Card, is, the actual physical hardware on a node or a host, which this cabling or this physical connection is going to attach to. Is there something available that you can utilize right now? Um, is the cost benefit of upgrading those interfaces or buying new physical interfaces, adding different NICs, different network interface cards to existing hosts for new cabling? Is stuff backwards compatible, or are you going to have to replace a bunch of equipment if you try to, utilize some new cabling and new physical infrastructure? What's the thought process behind that? You know, you might have SFP modules, which is a nice universal port that can run fiber, or it can run, almost any cable can run out of an SFP module. Um, what network interfaces, what transceivers do you maybe have in existence already? What can you use with what you have available? What are the financial constraints? It would be great if you could run fiber to everything. Would not be financially reasonable in most cases. Fiber is significantly more expensive than almost any other cable method to run. It's very difficult to terminate. You have to slice glass ends together and able to, in order to actually connect to it and utilize that cable. So there is some high costs associated with it, but there is high throughput, high performance. So in certain cases, fiber is going to be the best option. In certain cases, fiber is going to be unaffordable and it's going to be extreme for the needs. What utilizes existing infrastructure? Well, fiber's cool. If you already have fiber in there, different transceivers can utilize multiplexing where there's different light shades per channel, and you can run multiple channels through the same fiber cable just because of color, light color in that cable. Again, forwards compatibility or backwards compatibility with existing infrastructure. Make sure that you're not going to have to replace everything while making a couple physical changes, or see if that's within the financial constraints or the needs to truly replace everything. Going to bring us to the end of this episode. Again, we discussed the three major cabling types, the three major physical types, which is wireless, copper cable, which is usually Cat cable, Cat 5e, stuff like that, and fiber optics. They all have their use cases, and it's super situational to determine which is the actual best and most efficient physical connection between devices. It's a lot of research, a lot of site research, a lot of looking at existing stuff, a lot of looking at new stuff, a lot of looking at conduits, temperatures. It's a lot that goes into it. Every single time it's going to be a little bit different. So hopefully that's some base information to look for when it comes down to physical connections. We will mark that off on the books, and I will see you next episode as we discuss data link.